Also, it's not one.
What happened last night in the rain? Almost everything.
It's not wrong. Everybody knows they don't. Everybody knows they don't fall. They don't fall.
Oh, finally.
Who is it? That's not possible. Everybody knows that.
So, you guys will take a class next year, most of you, unless you're, do I have any eighth graders in here? So you guys are all ninth. So you guys next year, you'll all take geometry. Like that's the deal. 10th grade, you take geometry. And Mr. Manlove will talk to you a lot more next year about parallel and perpendicular lines. And when you talk about it in your geometry class, the way you talk about it is going to be different than the way we talk about it this year. So you guys will talk about angles and transversals and alternate interior angles and stuff like that. In this class, that's not what we're worried about. So I'm going to leave all of that to him for next year. What we're going to do this year is just study what happens with the slopes of two lines if they're parallel or if they're perpendicular. So what are parallel lines, first off? Yeah, so they lie in the same plane. They're straight lines, obviously, and they never cross each other. So yeah, if I were to sketch a pair of parallel lines, one of them might look like this, and then the other one would mimic it like this. Okay, so try to just sketch a couple of those into your notes. So other than the obvious, which Cruz already said what we need to know, and that is, of course, that they never cross. In my class, this is algebra. What is true about two lines that could make them never cross? That's it. And, you know, that question every year, the answer to that can take a minute. It can take 2 minutes. It can take, well, 2 seconds, which is what we got back here. So good work back there in the corner. Two lines like this that are parallel, what makes them parallel is the fact that they have the same slope. Thank you. And that, I mean, that doesn't have to be just two uphill lines like this. It could mean a pair of downhill lines like this. We would agree that those are parallel lines as well. So as long as they have the same slopes, then they're going to be called parallel. And it can be true for a pair of, oops, sorry about that. I forgot to switch to my drawing tool there. That can be true for a pair of horizontal lines like this. And it can also be true for a pair of course, vertical lines like this. So far, you're okay just conceptually with the idea of what it means to be parallel? So again, in my class for this year, when we say what makes lines parallel, we don't want to answer the question by saying they never cross, because like we already get that. And that was an important part of that definition. But when we talk about them in this class, we want to say they have the same slope. Okay, because we talk about slopes and intercepts and graphs more than you will next year in geometry. So again, in geometry next year, Mr. Manlove's going to have you cut a line through two parallel lines like that, and then you'll study the relationships between like this angle right here and this angle right here. But we don't go down that road in this class. Okay, yeah, those are called same side interiors. Very good. So again, that's all for next year. So in my class, we're going to worry about the fact that if two lines are parallel, then they have to have the same slope. Got it? So for half of this lesson, we're going to be writing equations of lines where I give you the equation of one line, and then I give you a point that the line goes through. It's going to be confusing at first. And then once you realize like what I'm asking you to do, the simplicity of it, then you'll just see right through it. You'll be like, wow, this is easy. I got this. So let me type you up a couple of examples. Before we get on to perpendicular, let's talk just for about 3 or 4, 5, 6 minutes just about parallel lines. So for our first math example, let's do this. So I'll give you a few seconds to copy that down. I have the advantage of typing, so I can go a little quicker maybe than your pencil can go. It is, yeah, the spacing on this, it's not very mathy, so let me put some spaces in there for you. How's that? Is that a little better? Yeah. Okay. This is one of these lessons where as a teacher, like I'm not surprised. 25 years ago when I started teaching this, I was surprised by how difficult people made this. Because I thought to myself, like, oh, this should just be more of the same. And then something about the wording of it can really get some people. Some people they get over it real quick and then done. But this is a struggle. And I want you to see that today we do have to do a lesson on this, and it is worth a day, but it's not anything that you don't already know how to do. Believe it or not, you already know how to do this problem. We've just never attacked it from this perspective before. Everybody got it jotted down? So let's go back to what we talked about 2 or 3 minutes ago. What does it mean for two lines to be parallel? They have the same slope. Good. Thanks for answering the question that way. So when I give you that equation, and I've kind of redded part of it out just to draw your attention to it, but when I give you the equation of that line, right away, you realize there's a couple things. First off, the y-intercept is obscene, right? Like I've never given you a line with a y-intercept of 589. But the thing about it is that that number doesn't matter. I don't really give a hoot where the line crosses through the y-axis. All I'm here for is the slope. So if I said to you, I need a line that's parallel to this line, and you just told me that that means that our lines have to have the same slope, right? And if the lines have the same slope, then that basically means I can go into the equation that someone gave me and I can just steal its slope. I basically reach into the equation with my grubby little fingers and I grab the slope because that's what I'm trying to mimic, and I steal it and I say, hang on a second. So you're just telling me to write the equation of a line that passes through this point and has the same slope as this? The slope is just has to be -3? Yeah. And you've done this before. So first, let's stop for a second and pause and make sure that you're okay with that concept. If I want you to make me a parallel line, all I'm asking you to do is give me a line with the same slope as the one I just gave you, correct? So what does that mean about the 589? What do I need to do with that? Trick question. Absolutely nothing. In fact, I can scribble it out. I don't even care because, again, like I said earlier, where it crosses the y-axis, that has no bearing on my life. I don't care where you cross the y-axis. I'm just going to make my own line and it's going to have the same slope as yours. So at this point in time, I can collect all of my information and bring this back to something that I'm familiar with. Okay, so you're asking me to write the equation of a line that has a slope of -3, correct, and passes through the point -4, 3. Correct. And at this point, if I can see that with clarity, I can get rid of all of the information above it and say, I can do this. I just have to get past all the words. Like this, the words aren't that big a deal. That's just we have to get it in here so that you understand that this is part of the deal. I have to be able to look at a line and make one parallel to it. So here's what we're going to do. we're going to do what we've done before. You remember this little guy? Y minus y1 equals m times x minus x1. Here we go. Let's take that purple equation and let's plug stuff in. What's it going to say? Y minus 3, and remember that came from right here where the little purple arrow is pointing. Remember, that's where we put our y coordinate, equals what? In parentheses. Nice job. Way to switch it to a plus. Remember that we go to plus when it's going to be minus, but if it's followed by a negative x or y, then we switch it over to plus. So far, so good? Okay, so what we're going to do now is we're going to change it over. We are going to be switching all of our answers now back into slope-intercept. And it's been a bit, like a real bit, like a couple weeks, I think, since we've done this. How do I get this purple equation to look like the yellow equation? What's step one? You have to distribute. So I have to take the -3, because I don't want the purple equations today. Okay, that's not going to be generally where we stop. So I'm going to take the -3 and distribute it through, just follow those yellow arrows, and my equation is going to say y minus 3 equals what? Good, and it's still not quite to Yellowville, right? What's got that one more last step? What is it? I got to add that 3 across. He's not supposed to be over there with the y. So if I add 3 to both sides like this, and I won't always show this much work, you know, I like to show a little bit at the beginning so no one gets confused. But if I add the 3 and those go away, I can now say, here is my answer. Y equals -3x, and what's the y-intercept? -9, put a box around it. It is done. It's a lot of words to just get one thing out of the problem, and that is, again, oh, so you just want me to steal his slope. Correct. Let's go again. Okay, and I'm not going to use as many words this time. I'm going to be more concise so it doesn't take some of you 3.5 minutes to copy it down. So this time, I want you to help me write the equation of the line that passes through the point 2, 8. It is parallel to the line y equals -1/2 of x minus 4. The purpose of this portion of the lesson is when we get out of this here in a couple minutes and we head over to the other side, perpendicular, is that every one of you has now cracked the code and you understand what all of this means. Parallel to this line. What does that mean? What does it mean to be parallel? Have the same slope, steal his slope. So you kind of put on your best black clothing and your little ski mask thing and you sneak in under the cover of darkness and you take this slope off this line and you say, I'm going to go ahead and borrow that. Just like that. And at this point, you can take this equation up here and you can just go, I no longer have any use for any part of you. I got what I came for. I wanted your slope. I stole it, borrowed it, maybe is a better word. And now I'm going to write an equation. What will my equation say now that I've done what I need to do? And I'm not going to write this every time, okay? But remember, every time our foot in the door is going to be y minus y1 equals m times x minus x1. So what will that purple equation say?
Y minus.
Yep. Thank you. Good job. And no switching to pluses this time because none of the x, y stuff was negative. So we just keep it as is. So that's our foot in the door equation. It is not our final answer equation. At this point now we have to convert it. And the conversion will always come from the yellow arrows, right? That has to be the next job. Get those parentheses gone. So I'm going to recopy the left side. I have y minus 8 equals. And what is that first yellow arrow going to give me? Yeah, like you don't have to do any math there. You just glue them together. And what's the y-intercept going, or not the, I shouldn't say that. What's the -1/2 times the -2 going to be? +1. And that's that basic skill stuff. If you don't know how I got that, that's just that basic skill stuff that keeps creeping in. Remember, the second yellow arrow is 1/2 times 2/1. That's what 1/2 times 2 looks like. You see it? I'll switch the arrow to green so you know what I'm talking about. This green arrow is a whole number times a fraction. So you make the whole number over 1 and then do your thing. And of course, 1 times 2 is 2, 2 times 1 is 2, and 2 over 2 equals 1. Last step, you add 8 and you'll be now at your final answer, which is y equals -1/2 of x plus 9. Box it up. Done. So far, so good? Any issues with that? Okay, how about this one? How about through the point? -56, 84. Parallel to the line x equals 12. What's weird about this one? It doesn't have a slope. And so like you're like, wait a second, Mr. Ahern, you just did 2 examples with me where you told me to go into the equation and steal his slope and then use it. But then I turn around and I give you an equation of a line that doesn't even have a slope. So this is where we have to switch modes and now say, this is not a math problem. You will have to do exactly 0 math in this problem. You won't have to multiply. You won't have to solve. You just have to think. So here it goes. This series of questions somehow has to get into your notes because I can't make your notes for you. I guess I could, but I certainly don't want to. You have to ask yourself this series of questions. What kind of line is this? It's a vertical line. So if someone, your bully math teacher, walks in and says, okay, I need you to make me a line that is parallel to a vertical line. Think hard now. This, again, not a math problem. How do you make a line that's parallel to a vertical line? You make me another vertical line. Do you understand that? So if I give you a vertical and I ask you to make me one parallel, you have to give me back a vertical. And how do we write the equation of a vertical line? X equals something. And in this case, obviously, I would pick the -56, and I am done. Here's what I can tell you. You can sit here right now, and you don't have to nod your head, but you probably agree that was a really easy problem. Mark my words. These are the ones that get missed the most on the quiz you're going to take this Thursday. Really happens. Crazy, huh? Let's go again. Because 84 is the y coordinate of the point, and vertical lines are not judged by how high they are. They're judged by where they are on the x-axis. Okay, so the y coordinate of a vertical point, like a line on a point on a vertical line, this point means exactly nothing. Make sense? That series of questions. What kind of line did he give me? What does he want? What will I make? Boom, boom, boom. Let's go again. Let's go through the point -126 and 4. So that's a point that's way out in quadrant 2. To get to that point, you'd have to go left 126 steps and then up 4. But we're not scared, right? And we want to go parallel to the line y equals -10. Once again, this should be a simple task. But I have to be willing to ask myself that series of questions. The moment the equation that someone gives me sticks out like a sore thumb, that's got to catch on my radar, and I have to say something like, okay, pump the brakes. What is that? Correct. And if that is a horizontal line, which it is, and someone asks me to make one that is parallel to horizontal, what will I make them back? Another horizontal. So now I just have to go big brain mode and say, okay, well, if I need to make one, then I know how to write the equation of a horizontal line. How are all horizontal equations written? Y equals a number. So obviously, since it's y equals, I'm going to pick the y this time. I do care about the height of the line when it's horizontal. So I just simply choose the y, circle it, box it, pat myself on the back. The negative 126 turns out means bupkis, nada. Good, good. Okay. The other side of this is perpendicular lines. So perpendicular lines, do you guys know what the definition of perpendicular lines? Let me draw you a pair of perpendicular lines, and you can see if you can figure out what it means. People like to say they cross, and it's like, okay, that's fine. But there's lots of lines that cross. But in all of these examples, yes, I'm going to be very deliberate when I draw these and make it look like they're not just crossing. It's what I think that was Gunner's voice back there. When these particular types of lines cross, they're not just crossing. They're making perfect 90-degree angles. That's what makes lines perpendicular. I don't know if you've probably heard that word before, but you see perpendicular lines all over the place. Like you could probably find 1,000 examples of perpendicular lines in this classroom alone. Everything you look at, every corner of every poster, the intersections of the supports for the drop ceilings, the corners of the whiteboards. I mean, they're everywhere, right? So those 90-degree angles are very special to us, and they are lines. The lines that make those corners are called perpendicular. It's P-E-R-P-E-N, per pen, and then D-I-C-U-L-A-R, perpendicular. So that's what that means. So again, we have to talk now about algebra. These would be great for Mr. Banlove when he has you out there with your compass and your straight edge and you're constructing a right angle. Oh my goodness. But in this class, anyone want to take a shot at what happens with the slopes of perpendicular lines? Like here, let me throw something out. If I told you that the slope of this line, the one I'm pointing very carefully at, is 2/5, I'm just making that up. Anyone want to throw out a guess as to what the slope of this line is? It's definitely negative, Landon. Thank you, thank you, thank you for switching it to negative. So that's lesson number one, right? If one of them's positive, the other one has to be negative. But do you think that negative 2/5 looks reasonable for this? Doesn't it look like it's going like a lot steeper than the one that it was perpendicular to? You want to take a shot? Say it again. Yes. It is negative and upside down. So you switch the sign and you also do what's called the reciprocal, called the switch flip. Switch flip, switch flip. So you switch the sign, flip the fraction. How about this one? What if I pointed to this yellow and I told you that the slope of that line is negative 1/3? This one would have to be positive 3, right? It's the switch flip. I switch it from negative to positive or positive to negative. I switch it, whatever that means to you, just whatever it is, do the opposite, and then flip it upside down. I can't really say the same for horizontal and vertical. So if we look at my red example, we can't say that I flip it because, as you know, this one has a slope of 0, right? And what does the vertical one have? It has no slope. So the only time when you're really not going to use the whole switch flip technique is when it's a horizontal and vertical line. It doesn't really apply in a case like that. You can make a case that it does, but I'm not going to go there. So far, so good? All right, then let's do a math problem. All right, here we go. So we are going to work together to write the equation of the line that passes through the point -6, 10, and is perpendicular to the line y equals 2x plus 5. So this is the same sort of idea. I'm going into the equation and I'm putting on my best dark black outfit, waiting until the dead of night, and I'm going to sneak in there. And with my very careful fingers, I'm going to steal the slope from the line that someone gives me. What is the slope of this line that I just circled? His slope is 2, right? His slope is 2. So I take it and I steal it and I bring it back to my lab, my factory. And I say, okay, I don't want to use the slope of 2. I want to be perpendicular to 2. So what slope will I use? Negative. And then I flip the 2 to make it 1/2. And I'm right back to where I was before. Again, I think to myself, wait a second, so I can just throw all of this away now? Yes, you can. You got what you came for. You stole his slope, and then you ran it through your little factory lab. You flipped it, changed the sign, and said, I'm good to go. So what's my purple equation going to say this time? Given this information in the purple jelly bean up here, what's it going to say? Y minus 10 equals -1/2 x plus 6. And if that doesn't feel like it's the same as what we just did, I don't think you're paying attention. The only difference between parallel and perpendicular is I've got to tweak the slope a little bit if it's perpendicular. So let's finish this one out. And again, follow the yellow arrows because the yellow arrows are always going to be the next step. So I'm going to take the left side, copy it down. What is my right side going to say? -1/2 x minus 3, because half times 6 is half of 6, which is 3. And what's the last step to finish the job? Add that 10 across and you get y equals -1/2 of x. And what's -3 plus 10? Definitely +7. Stick a box around it. Done. Easy peasy, right? Let's go again. This time, we're going to go through the point -12, 25, and we are going to be perpendicular to the line y equals -3/4 of x plus 112. Right now, you're either feeling like you get this or you're really confused. And if you're really confused, you're in that group. I kind of talked about this earlier of people who's reading too much into this. The new wording of it has maybe got you down. Think about, what do I need? I need a slope and I need a point. So again, under the cover of darkness, I sneak in and I go into this equation and I say, hopefully no one can see me doing this. I'm going to borrow the slope and I'm going to write it down. This one has a slope of -3/4, right? But I don't want to be parallel to him. I want to be perpendicular to him. So I run that slope through my little machine. And which slope will I get back out? +4/3. Very good. And you're like, okay, I think we're right back to where we were before. And you'd be correct if you think that. Here we go again. What's my purple equation going to say? Y minus the y coordinate 25. At this point, if you wanted to in your notes, you could scribble all of this stuff out. I mean, you probably don't want to because then your notes aren't going to make sense, right? But like, you don't need it anymore. You got what you came for. You stole his slope. You're done. And then what's the rest of the purple equation going to say? Equals what? 4/3 and then in parentheses. Very good. So far, so good. Yellow arrows to the rescue. Again, it's time. It's always going to be time for this. Always free the parentheses, get the stuff out. Left side, you don't mess with yet. It's just y minus 25 equals. Now, first yellow arrow is just 4/3 of x, right? You don't need a math degree for that one. This one could be a struggle for some of you. Do the hook. If it works, let's see if it works. 4/3 times 12. It works. So follow the hook. What's 12 divided by 3? What's 4 times 4? Boom. So just stick a 16 there. If the hook hadn't worked, then I would have just multiplied. I would have put the 12 over 1 and just multiplied across. Got it. Okay. Last step is to add 25 to both sides. What is 16 plus 25? So our answer is y equals 4/3 of x plus 41. Put a box around it, pat yourself on the back, done. We're almost to the end. This is it, home stretch. I would like you to help me write the equation of the line that passes through the point. -12, 2, and is perpendicular to the line y equals 81. If you're following along, not sleeping, you're like in the moment, you've been absorbing all these examples, you know right where we are in the lesson now. This is not like the last problem that we did. The last two problems that we did, why? Because this one doesn't have an X. And so again, I have to put on my big kid, my smart kid cap and say, who are you? Yes, not almost. If it were parallel, then you'd be perfect. What kind of line did I give you? I gave you a horizontal. So think about that. Go big brain now. I gave you one of those. What's perpendicular to one of those? Come on, answer the question. What's perpendicular to one of those? What's perpendicular to that? Thank you, Gunnar. The voice of reason from the back. Perpendicular to horizontal is what I want. Therefore, I don't want another horizontal. I don't want another one of those. I want to make one that's perpendicular to it. So I make a vertical. And how do I write the equation of a vertical line? X equals, and which one do I pick? Obviously, the X. So let's be clear. The answer to this problem is not -12. It is the equation of the line X equals -12. And then, of course, finally, last one, and then we'll get to work. Well, you thought wrong. Sorry. Let's go through the point -8, 15. And we're going to go perpendicular to the line. X equals 6. Again, I can't do this for you. I can only try to hope, pray that you are still in the moment and ready to listen and willing to go. What is that line? Very good. So I gave you a vertical. You agree? I need a horizontal. Good, Cruz. If I want to be perpendicular to that red line, then I need to be this red line. And how do we write the equation of a horizontal? We write y equals, and the moment we get that out, we pick the correct one, put a box around it. Done. Got it? I did not make photocopies of today's assignment. It is a PDF, and it's not quite on Canvas yet, but I will quickly, publish that. It should take me about 10 seconds, and then you'll hop on Canvas, and that's where your assignment will be.